Hello, my name is Rongie Roales, and now I'm going to present my course project for Data Communication and Networking 1. The topics that I'm going to discuss on this presentation are networking fundamentals, network types and topologies, and network models. Now, let's discuss first networking fundamentals. Computer network. A computer network is a set of computers connected together for the purpose of sharing resources. Through network connection, computers are able to share file, internet access, printers, and etc. Components of the network. We have end device, or what we call also hardware components. These are the computing device that interconnects, which has an IP address that is unique for every computing device, such as laptops, personal computers or PC, printers, workstations, smartphones, IP cameras, and etc. Intermediary devices. These devices provide connectivity to the network, connect individual networks, and connect segments within the same network. Commonly used network devices. We have Ethernet hubs. This is a device connecting multiple computers together and make them perform the function as a single unit. We have also switches. This is a computer networking device that connects devices together on a computer network. We have also routers. These are small electronic devices that join multiple computer networks together via either wired or wireless connections. We have also network card. Network cards, also known as network interface cards or NICs, are hardware devices that connect a computer with the network. Lastly, we have modems. This is a device or program that enables a computer to transmit data over, for example, telephone or cable lines. These are the representation of network device or our components. Categories of network components. We have three categories: the end devices, network infrastructure devices, or what we called also intermediary device, and we have network media or media device. So I'm going to show you after. This are the examples of our end devices: computers, handheld devices, printers, cameras. For a network or intermediary devices, we have switches, routers, and firewalls. For network devices or network media, or the cabling that enables connection between different devices, we have copper, fiber optic, and wireless. To show you that one in our Cisco, let's open our Cisco Packet Tracer. From here, we can see the icons for end devices. So we have example of our end devices here, like we have PC, we have our laptop, server, printer, and IP phone. All of these are examples of our end devices. Now let's see these network devices or our intermediary devices, where we have an example of router. We have also switches, and also example of intermediary device is our hub. So last is the connection of the two devices, or what we call media. In this icon we have the connections. As you can see, let's use this automatic connection. Let's connect the router to our switch. So you can see we have here a connection of what we call copper straight through connection. And then let's connect this laptop to switches. It's the same. Laptop to our server, or to our hub. Sorry. Or I will just add another switch. As you can see, the connection that's showing here is copper crossover. So that's the example also of media. Now let's return to our slides. Now let's proceed to the next lesson of discussion, the network types and topologies. Let's discuss first the local area network, or what we all know as LAN. This is an individual network that usually spans a single geographical area, providing services and applications to people within a common organizational structure. Next, Metropolitan Area Network, or MAN. A MAN usually interconnects a number of LANs using a high-capacity backbone technology, such as fiber optical links, and provides uplink services to WANs and the Internet. We have Wide Area Network, or WAN. A network connection between two or more LAN over a potentially large geographic distance. Client-server model. The relationship between clients and servers is known as the client-server model. Now let's proceed to the network topology. In network topology, design is the arrangement of the computers in a network. First, the types of topologies. We have here bus topology. Bus topology is a network topology in which every computer and network device is connected to a single cable. So let's open again our Cisco Packet Tracer. First, let's remove all those devices that we used before. Okay, to show an example of bus topology, let's have at least 5 PC here. And I will also put 5 switches. Now, using the automatic connection, let's us first connect all our switches. Now, let's connect our PC to each switch. So this is an example of our bus topology, where it says topology which every computer and network device is connected to a single cable. So to do that, we use switches to connect our 5 PC. So we have also here another topology, ring topology. This is a topology that forms a ring as each computer is connected to another computer or switches or intermediary devices with the last one connected to the first. So let's open again our Cisco packet tracer. Let's remove the connection. So to do that, using these 5 switches also, let's make it in a round formation. So it says the devices is connected from first to the last. So let's connect all our switches first. As you can see, the first switch is connected to the last switches return to the connected again to the first switch that we have. So now let's just connect our PC to each switch. And we have here our example of ring topology. Let's return to our presentation. Another type of topology is the star topology. This is a type of topology. All the computers are connected to a single hub through a cable. So let's return again here in our Cisco packet tracer. Let's remove first all the connection that we have. So let's have at least one switch. So all these 5 PC, we will connect all those 5 PC in one switch. So as you can see, all our 5 PC is connected in just one single switch, and this is showing a star example of a star topology. So let's continue our presentation. Now let's discuss the network models. Network model is a set of network layers and how they interact. The following are the two most important and well-known network models. OSI model, or the Open System Interconnect. TCP IP model, or what we call Transmission Control Protocol, Internet Protocol. Layers of the OSI model. The first layer is the physical layer. Second, data link layer. Third, we have network layer. Fourth, our transport layer. And the fifth layer, our session layer. Sixth, our presentation layer. And the seventh layer, our application layer. So the application layer, or the seventh layer of our OSI model, is the topmost layer of the OSI model. This layer provides a means for the user to interact with the software application. The sixth layer, the presentation. This layer provides proper common data format that is sent across application layer services. The fifth layer, or the session layer. This layer establishes, manages, and terminates connections between applications. This layer provides services to the presentation layer. Fourth layer, our transport layer. This layer defines services to segment, transfer, and reassemble data individual communication between the end devices. The third layer, or our network layer. This layer provides services to the exchange the individual pieces of data over the network between identified network devices. Data link layer, or the second layer. This layer provides methods for exchanging data over a common medium. And our first layer, the layer of the TCP IP model. We have application layer, transport layer, internet layer, and network access layer. So, application layer, the layer 4. This layer represents data to the user, plus encoding and dialog control. Transport layer, the third layer, supports communication between diverse devices across diverse networks. Internet layer, or our layer 2, determines the best path through the network. And the first layer, our network access layer, controls the hardware devices and media that make up the network. So for comparison of our OSI and TCP IP model, OSI lost out to TCP IP as the protocol suite of the Internet. The TCP IP model is mapped to the OSI model. TCP IP is the protocol used today, but OSI model is often used to describe network communication. And that's the end of my presentation. Thank you. Now I'm going to discuss the second part of my course project, answering this given question. So I'm going to explain my answer for the first question is /27. Because as you can see, 255.224, so it's 8 plus 8 plus 8 equals to 24. So the remaining 3 are, so the remaining 3 is 128 plus 64 equals to 32. If you will add this all, equals to 224. Second, my answer is 172.201.95.255. Because the end of this network address, this one, should be the broadcast in the end at 255. Number 3, my answer is 255.255.255.128 is another plus 1 subnet, so it's 125. Number 4, my answer is 10.10.78.129 because the gateway should be additional only one of the IP address from our IP address. Next, number 5, my answer is first 11000000 because it's 128 plus 64 equals to 192. For 84, it's 64 plus 16 plus 4. For our 235, it's 128 plus 64 plus 32 plus 2 plus 1 equals to 235 and 0000. Number 6, again we just need to put in the end 255, so it will be 192.84.235.255. Number 7, my answer is slash 26 because 128 plus 64 equals to 192. So this is 24 plus 2, 24 plus another 2 equals to slash 26. Number 8, my answer is 172.99.184, and again we need to put the end 0.255. Number 9, my answer is for this one because if we will calculate to get the 205, we have 128 plus 128 plus 64 plus 8 plus 4 plus 1, and for our 36 we have our 32 plus 4. For 72 we have 64 plus 8, and for our 56 we have 32 plus 16 plus 8. For our last number 10, my answer is 205.36.72, again putting the 2.2.255 in there.